In this recording, we're going to talk about the relationship between diminishing MRTS and diminishing marginal productivity. Basically, what we tried to answer is, in case if you have diminishing marginal productivity, will it always ensure that MRTS is going to be diminishing? So let me just recap a few things before I move on. So you have X, you have Y, and you have the isoquant like this. Your Q naught is equal to f of xy. I think in place of xy, we should rather use KL. So you have L, you have K like this. Fair enough. So this is what my isoquant is. And let's say we are sitting at this point. So the MRTS is defined by the slope of this line. That is, let's say this is point A or something. So this is the high ratio of K to L. You have huge amount of K and you have less amount of labor. So it means that MRTS is large, indicating that you can give up high amount of capital in order to get one more unit of labor, right? At this particular point. So MRTS is large along this. So for high ratios, please write. For high ratios of K to L means capital is more, labor is less. MRTS is large. MRTS is large. What does it indicate? That you can give up high amount of capital to get one more unit of labor. Indicating that great deal of capital can be given up. To get one more unit of labor. That's what it is. Now, if you look at MRTS, let's say at this point, now you have labor more relative to capital. So at this point, you do not want to give up more amount of capital in order to get one unit of labor. You already have huge amount of labor with you, right? So you do not want to give huge amount of labor to get one more unit of labor. No, right? Please right. When a lot of labor is already used, right? MRTS is low. So what does it signify? It signifies that you do not have much capital with you, but you have huge amount of labor, and you would want to give very small amount of capital in order to get one unit of labor. So, right, signifying that the small amount of capital can be traded for additional unit of labor, right? For additional unit of labor. Of course, I mean, this all of this is holding true if output is held constant. If output is held constant. Hmm. So here MRTS is high, here MRTS is low. So as you move along, move down and right along the an isoquant, you'll find this that MRTS is falling. MRTS is falling. Now the question is that it is not possible to derive diminishing MRTS just by the assumption of the diminishing marginal productivity of labor and capital, because marginal productivity is not the function of, say for example, marginal productivity of labor, that is not the function of only labor, that is the function of capital as well, right? So it depends upon the other input also. So you cannot derive diminishing MRTS just by having an assumption of diminishing marginal productivity, right? So for example, you have this curve with you. Q is equal to f of k. F of k is greater than 0, f of L greater than 0. What does this signify? That marginal productivity is positive. It signifies this. While fkk is less than 0, fll is also less than 0. This is what does it signifies? That marginal productivity is diminishing for both labor and capital. Diminishing marginal productivity of both labor and capital. Guys, I think I can use this now. I have explained all of this in the last class. Uh, that is, these are FKFL positive, FKKFLL negative. So we are just using that. Okay. Now, if I want to show that the MRTS is falling, so what is it that I need to show? That dMRTS by dL is negative. So if I want to show that MRTS is falling, so I want to show that as your L is increasing, MRTS is falling. That means dMRTS by dL is negative. This is what I want to show. So what is MRTS? Is FL by FK dMRTS alpha K upon dL. This is, I'm again telling you, you understood this. You want to show that as L is increasing, MRTS is falling. That slope is falling. So this is what I want to show. So derivative of this with respect to L. So basically you meant this. MRTS is what? FL by FK DL. Right. Guys, I hope you also remember this guy, that it is minus dk by dl is equal to fl by fk. This also you derived in the last class. Minus dk by dl is equal to mpl by mpk, which is fl by fk, right? Okay. Use quotient rule, beta. For this, use quotient rule. Fl by fk. Guys, again, one more thing. When you say fl, that fl is the function of lk. When you say fk, that fk is also the function of fk. This is not only the function of L, this is not only the function of K. So this marginal productivity of labor is also dependent upon capital. Marginal productivity of capital is also dependent upon labor. So I'll rather put it here. So if I want to just differentiate this, okay, I'll come back to this point, but I just want to say, if you want to just differentiate this guy, so how do you write this? FLL, FLL, DL by DL, that is 1, plus FLK, DK by DL, right? This is the derivative for this. If you want to differentiate this guy, what will happen? FKL, FKL, your DL by DL, that is 1, plus FKK DK by DL. Is that right, beta? You understood this? What is it that we have to, because we'll be using this guy. Now you think about it. I have to use quotient rule at FL by FK. So denominator as it is. But the denominator is what? Your FK square. Like this. FK square. Okay. Just the quotient rule. Then denominator as it is into the derivative of numerator. Derivative of this FL, which is this guy, which you have just written. Which is what? FLL plus FLK dk by dl minus numerator as it is into the derivative of denominator, which is this guy, FKL plus FKK dk by dl. Beta? Right. But you also know this guy, that dk by dl is equal to FL by FK minus dk by dl is equal to FL by FK. So what is dk by dl be equal to minus FL by FK? So wherever dk by dl is, I will be substituting minus FL by FK. So it is FK FLL plus FLK minus FL by FK. Minus FL FKL FKK minus FL by FK. Beta? Whole upon FK square. Now after certain algebra, you guys can probably, I'm sure that you can take up what do you call the LCM here. It becomes FK square FLL minus, okay, I'll do it, FK square FLL minus FL FLK minus FL FKL. So this becomes what? Minus, or this minus becomes plus FL square FKK. So this is FK beneath both of them. So it goes in the denominator and it becomes FK cube. Like this. Right. So there's something which is called Young's theorem, which says the cross partial derivatives are equal, right? If your function is twice continuously differentiable. Hmm, minus FLK minus FLK plus FL square FKK whole upon FK cube. Mm-hmm. But this is little involved, but I'm sure that you guys can do it. So this is what? FK square FLL minus 2FL FK FLK plus FL square FLK, right? Okay. Now you have already assumed that Fk is positive, marginal productivity of capital is positive, so denominator is positive. You want to show that MRTS is falling. Denominator is positive, so dMRTS by dL would be negative if numerator is going to be negative, right? When numerator is negative. If numerator is negative. So what is numerator out here? Numerator is Fk square FLL minus 2FL Fk FLK plus FL square FLK. Now you want this to be negative. Let me just put the signs first. Fk square is positive. FLL is diminishing marginal productivity of labor. This is negative. So this term is negative. What about this term? FL square is positive, and this is FKK, not FLK. This FKK is negative, so even this term is negative. So if the this term will also becomes negative, then surely the numerator is going to be negative. So FL is positive, FK is positive, this minus is there. If the condition is if FLK is positive, then only this entire term is going to be negative. You know? So it all depends upon how is this FLK behaving. How is this FLK behaving? So just by assuming that you have a diminishing marginal productivity of labor, FLL negative, just by assuming that you have diminishing marginal productivity of capital, FKK negative, you can't just say that your MRTS is falling. You also need an extra assumption that FLK is also positive. FLK positive means cooperative factors, right? So you guys can write this, that numerator will be negative if FLK is positive. If FLK is positive means the factors are cooperative. Hmm. So what is it that you have proved? You proved that just by having marginal productivity which is diminishing, you cannot ensure that your MRTS would also be diminishing. So MRTS would be diminishing, which would be diminishing when in addition to diminishing marginal productivity, you have factors which are cooperative, FLK positive. You have factors which are cooperative, right, beta? So this is what I wanted to do in this class, right? Thank you.